Friends, let us now understand what do we mean by steradian, what do we mean by that, and what is the physical quantity which this unit actually measures. So before we look into steradian, let's look at a common unit which we already have used and we understand it very well, and that is a radian. So a radian measures an angle. So what is an angle? So angle we already know, right? For example, if we have a circle here and I have cut out an arc of this circle, right? So this is an arc of a circle. And if I take this arc backwards, then there is an angle which this arc subtends. So that's what we say. So this arc subtends an angle at the center. So I can measure this angle. So you can measure it angle using protractor, for example, which would give you an answer in degrees. Okay. But we have another unit instead of degrees for measuring this arc, or for measuring this angle, and that is known as a radian. So what is a radian? So if this radius is equal to, let's say, r, and this arc length is also equal to r, then the angle subtended by this arc length or this arc of length r at the center of the circle whose radius is r will be equal to 1 radian. So that is how 1 radian has been defined. If I create an arc same length as the radius, then that arc would subtend an angle of 1 radian at the center of the circle. So very, very simple. Okay. So now we understand what is a radian. Okay, and what is the physical quantity? Of course, that is a two-dimensional angle. Okay, so this is a two-dimensional angle. So we'll just write it here, 2D angle, that this radian actually measures. So as soon as we write 2D angle, the first question which will pop into your mind is, sir, is there a 3D angle also? So I will say yes, that is the point of this class. Okay, so we also have 3D angle, and we can very, very easily understand it using this cone. So there is an angle right here at this tip of the cone, and we call it a 3D angle, right? So if you look at this cone, there is a three-dimensional angle kind of formed at this point. Okay, so this two-dimensional angle formed at this point, and there is a three-dimensional angle formed at this point. So this and everything is sort of emerging out from this point. The thing that is formed here, we call it a 3D angle or a solid angle. Okay, so that is a 3D angle. We call it solid angle. Okay, and how do we measure that solid angle? We measure that solid angle using unit known as steradian. Okay, very, very simple. Okay, so understand the concept of solid angle. Now we can understand what a steradian is actually is. So imagine that this cone, it came from a sphere. Okay, so we can imagine that it is very, very simple. It is actually, that is the diagram which is drawn here. Okay, so there is a sphere, and this cone was actually part of this sphere, right? So it is right there. You can see that this cone has been taken from a sphere. If the area at the top of this cone, if let's say that this is r squared, okay, this is r squared, and the radius of the sphere is actually equal to r. Okay, so the radius from which this the sphere from which this cone has been taken, okay, this is the cone, is actually equal to r, and the area of the face of this cone, at the face of this cone. Okay, imagine, but this is a flat area. Here we have the area that we have shown you is actually the area, the curved area on the surface of the sphere. Okay, but that does not really matter. But the thing here is, understanding here is that, imagine that this is also curved area. Okay, but the main thing here is that if this area is equal to r squared, and the radius of the sphere from which this area has been carved out is actually equal to r, then the angle which is subtended by this area at the center of the sphere, right? So this area is subtending an angle at the center of the sphere. We will say that that particular angle is solid angle is equal to 1 steradian. Okay, and we have to be careful. We will call it solid angle because it is covered. It is kind of emerging out from that point in three-dimensional space, and that is why we call it a solid angle. Okay, and we say that that solid angle will be 1 steradian. So again, to summarize, what is 1 steradian? On the surface of the sphere, we take an area equal to r squared. Radius of the sphere from which we have carved out this area is actually equal to r. Then the angle which this area would subtend at the center, the solid angle which this area would subtend at the center of the sphere would be equal to 1 steradian. Again, very, very simple, not difficult concept at all. But here are two extensions of it. So far what we have seen is that this particular cone has been a right circular cone, right? So what is a right circular cone? Right circular cone, if I draw a line from this point of this solid angle to the center of this circle, okay, it will fall perpendicularly, and that is what this the right circular cone actually means. So far that's what we have shown you, and of course in this right circular cone you will say that, sir, oh, there is a solid angle created at the tip and we can measure it, of course, in terms of Steradian. But it does not necessarily have to be case. Okay, this does not really have to be a right circular cone. I can create any object. So for example, here I have taken an irregular object. You can extend it, and this irregular object, this irregularly shaped object, I can then form a cone around it and then project it backwards to the center of the corresponding sphere. And even this irregular object would actually form a solid angle, right? So that's the one thing to note, that all objects, right, whenever we see, for example, we are seeing any object, light rays are coming out from that object and entering my eye, and those light rays would actually form a solid angle at the eye. Okay, so any object we can form a solid angle if we go backwards in a conical fashion, if we converge that solid object to a point. That's one thing. The second important thing is the solid angle. To form a solid angle, I necessarily need a two-dimensional space or a two-dimensional surface. Okay, so this can be a two-dimensional surface, or it can be a three-dimensional objects. So three-dimensional object also, I can convert the light rays from there to a point, okay, and I can create a solid angle. But I need at least two dimensions to go backwards and form a solid angle. A solid angle can never be formed by a point object. So if there was a point here, then I cannot really convert it back. Or if there was a line here, simply imagine that there is a line here, then that line can actually not converge and form a solid angle going backwards. Okay, so that is the minimum requirement. Solid angles can only be formed by 2D objects or 3D objects. So that's another thing. The third important thing I wanted to get across was, why are we even studying this, right? Why do we need to study solid angles? It kind of seems quite unnecessary to create another physical quantity and then learn it. See, the thing is, it is like we have seen in our example also, the solid angle becomes very, very important when we are dealing with optics, especially when we are dealing with point sources of light. So if there was a source of light right here, then light rays would emanate from it in this conical fashion along the surface of this cone, and then I can measure what is the intensity of light here, and all of those calculations involve the solid angle which is formed here. Similarly, light rays which are coming out from an object and entering my eye, for example, they would also form a conical shape and converge at my eye, but that convergence would not be a 2D angle, that would be a 3D or a solid angle, and again I'll have to use the concept of solid angle at that point. So hope this concept is clear. It is very, very important. Thank you very much.